Okay. All right. Where did we stop? Izolo.
On question 8.3.
This one. This is the one we're supposed to do. I remember.
Yes.
Okay. So, is your network not as bad today?
Yes.
Okay. So, let's go through 8.3. In the diagram, A, B, C, D is a parallelogram with diagonals intersecting at E. The diagonals is obviously, so the parallelogram, let me just putting my drawing tools here. Okay. So parallelogram A, B, C, D is this one. Then the
Yes.
diagonals is DB and AC, and they all intersect. Intersect means they meet or cut at point E. Do you understand that?
Yes.
Okay. Now, then it says the diagonals of parallelogram DECF. This is a different parallelogram. DECF, like I said, using your colors is important and visualizing. DECF is this one. And they say that diagonals of this parallelogram meets at this point G. So it has a diagonal DC and diagonal EF. But you should notice that this diagonal DC is actually one of the sides for AB. I mean, one of the sides
Yes.
for the parallelogram ABCD. And this diagonal EF, half of that diagonal is in the parallelogram ABCD, the other half is in the other parallelogram. Do you see what I'm trying to point out?
Yes.
Then, okay, now we read on the diagonals of parallelogram FGCH. Let me use a darker color, bright, warmer color. FGCH. There's that parallelogram. Intersect at K, the diagonals GH and CF. Do you see that?
Yes.
Now they say prove that DB is equal to 4KC. Where is DB? DB is this diagonal here. Can you see it?
Yes.
Now, what did I say? What advice did I give you yesterday? I said something about what is the best way to approach, or sometimes the way to approach geometry. I said, which way do you think? Think, what did I say? Do
You
you
said
remember?
that we should break things down.
Mm-hmm. And think backwards. Do you remember?
Yes, think backwards. Yes.
Yeah, so it's very helpful because sometimes when you think in the forward direction, it gets very, very confusing and intimidating. So when you think backwards, it helps a lot because it forces you to trace your steps. So in this case, they're asking you prove that dB is equal to 4kc. So if you think backwards, you start where you ended. So where is our ending point? Our ending point is dB. So let's go to dB and look at it. There's our diagonal dB. Do you see that?
Yes.
Now, forget the kc now. Forget the kc. You work backwards with what you know. Don't try and create a link between dB and kc immediately. That's another thing you should take note in maths. You always do what you know. Even if you don't see the link between what you know and where you're supposed to go, keep doing what you know because usually, most of the time, doing what you know leads you to the part that you don't know. And then the puzzle all comes together. Does that make sense?
Yes.
Okay. So now, DE. So now, DE. So if you look at DB, so what can you tell me about DB? DB is this. What can you tell me? Can you analyze it and tell me something that you see about it?
DB is parallel to FC.
Okay, that's one. Okay, fine. Tell me another thing.
DB is a a diagonal in a parallelogram ABCD.
Correct. Another thing. So okay, that's good. So far you're on the right track. So let me try and give you another hint. So we said yesterday diagonals bisect. So now there's a hint for you. Diagonals bisect. What did that mean? What does that mean? Now look at bisect DB and tell me what can you say?
Bisects DB.
Sorry? Okay, let me help you. So when we said bisect, we mean that this side is equal to that side, and that is your midpoint, right?
Yes.
So then DB is actually equal to what?
To EB.
Yeah, you're right. Either you can say DE times 2 or EB times 2. That's where you were going with this, right? Because
yes.
E and DE are the same size. So if you take DE, you times it by 2, you get DB. Take EB, you times it by 2, you get DB. So that now we're on the right track. So instead of using EB, you see KC. Where is KC? The KC we want to get you is here. Do you see that?
Yes.
So if we use EB, it's further away. So we rather use DE because DE is closer to KC than EB is. Are you following now?
Yes.
Yes? Uzile, are you here?
Yes.
So we now we're gonna use DE to try and get our point across because DE is related to DB. Now we're on DE. What can you say about DE? In fact, you can
DE,
make it. Yeah. Okay. Yeah. Continue.
DE is also parallel to FC. It's
perfect. Parallel, and there's two other things you can
the same.
It's the
and
same.
It is the same as all other sides.
No, it's a parallelogram, so not all of them are equal.
Oh,
it's this.
It's opposite side. The opposite side of DE is equal. Are equal.
Yes. So DE is equal to FC.
FC.
Now, actually, FC gives you, it links you to KC. So you're almost there.
Yes.
So now, you can actually rewrite FC in terms of KC. So how can we write FC in terms of KC? Can we? Think about KC is here. Yes, KC. FC is the entire line. So what can you say? Think about it. Okay, look at the parallelogram FGCH. That will help you to know what is the relationship between KC and FC. Look at the parallelogram FGCH. That will help you get the relationship between KC and FC.
We can say KC times 2.
Perfect. So now DE, okay, is equal to FC, but FC is actually KC multiplied by 2. Are you following?
Yes.
So now, okay, I haven't been putting reasons. Let me just put a reason here. For here, your reason you could be your diagonal. You can just say diagonals bisect. That could be a valid reason. Diagonals bisect. So that could be your reason. Diagonals bisect. Cool. Are you following?
Yes.
Okay, great. Now, so there's a reason. Here, DE is equal to FC. We needed a reason for that. We can say that opposite angles of a parallel or opposite sides of a parallelogram. Because what we know, opposite sides of parallelogram are equal. So that was our reason of saying that DE is equal to FC. So this is a short way of writing parallelogram. We use a parallel symbol, then use apostrophe ogram. Are you following?
Yes.
Okay, great. Now we're almost there. Now you have DE in terms of KC, but DE is actually related to DB. So can you suggest what are we going to do now? Because we literally done. But I want you to put the pieces together and then you'll get everything. Yeah? So what happens? What comes next?
Can we say DB is equal to KC times 2?
Correct. But remember, KC times 2 is only replacing this DE part. You'll still have that times 2. Do you see that?
Yes.
So the DE part is going to be replaced by KC times 2. And then we're still going to have to multiply by that times 2 because that was not substituted by anything. So then DB is equal to KC times 2. Where does the KC times 2? We replaced the DE with KC
Excuse me?
times 2. Then there's another times 2 that we originally had there. Then 2 times 2 is
4.
4. 4 times KC is 4 KC.
KC.
Then we are done. That arrow means in mathematics that we are now done. Do you see that?
Yes.
So that's the final answer for this. This is the final answer. Is there any questions that you have on how to approach this question?
I want to ask that isn't this question, shouldn't we have answered this question the same as the recent question where we proved congruence, or is that only for angles?
You could try, but it won't work out. No, because I think you won't have enough information. It'll be a lot harder here to use congruency. It's something, of course, I won't say no because I'm happy that you are thinking this way because mathematics is like a toolbox, and you are like a mathematician, so you are now looking at your toolbox and you're questioning, can I try it? I think technically you could try it, but I don't think it will be that easy. In fact, I think it might not even work because if we tried, okay, let's say we tried, then you would have to compare this triangle. It's gonna be a lot difficult because then you have to think about which triangle to use. I think it's just a lot more difficult, but I'm sure you can do it that way. So for a question like this, if you can try congruency, try it, but I think it's just going to be a lot harder. Whereas if you use the properties of a parallelogram, things such as your knowledge of diagonals and the opposite sides, it's a lot easier. Because this is a very quite easy to understand, especially once you've color coded the picture. Does that make sense?
Yes.
Okay. So now we have our last question, question 9, then we're done. Question 9, I'm going to try and zoom out. Can you see it still?
Yes.
If I zoom out once. Okay. Now, question 9. Let's forget it. Triangle ABC is right angled at B. There it is. F and G are midpoints of AC and BC. So F is a midpoint of line AC and G is a midpoint of BC. So H is a midpoint of AG.
Hello?
Hello,
Oh.
can you hear me?
Yes.
Okay. And then E lies on AB such that FHE is a straight line. Now it says that prove that E is the midpoint of AB. Now, before we do this, I'd like us to review something called the midpoint theorem. So that's basically the thing the approach you're gonna take is the midpoint theorem. So so I want us to look at through the midpoint theorem because that's the easiest approach to use. Then we can come back to the question. So let's look at the midpoint theorem. What did I do now? Can you still see my screen? I'm on Google.
Yes.
Okay. Now let's just go into the midpoint theorem here. So midpoint theorem is like this. If you have a triangle, let's look at the statement. I want us to look at both at the statement and the picture. The midpoint theorem states that the line segment in a triangle, so say we started with triangle ABC, the big triangle. Can you see that?
Yes.
Then we make midpoints D and E. Then we have midpoints D and E. Then we draw a line that joins midpoints D and E. That line, the midpoint theorem says that that line that goes through the midpoints will be parallel to the third side, which will be BC, and it will also be half the size. So in other words, this side here, DE, is half the size of BC. So maybe I should try and do this. Let me try and show you something here. Let me try and we'll come back to that page. So let's say you start off with a triangle like this. Triangle A, B, C. That's your triangle. So that's your triangle. And then we put in midpoints here. You know what is a midpoint, right?
Yes.
Point at the middle of the line, right at the center. So then between A and B, our midpoint, let's let it be F. So midpoint of A and B is F. And then between A and C, let's have another midpoint. Let's call it G. You understand?
Yes.
So now this is what the midpoint theorem says. We started off with midpoints. There we have. Then what happens now? We join the midpoints to make a line. Okay? So now what the midpoint theorem says then, that line that joins the midpoint is first of all parallel to the third side. So it's the third side being this one.
No,
CB.
I'm saying it's CB.
Yeah, it's parallel to CB. But also, it also says that FG is actually half of BC. Sorry, I'm just half of BC. That's what it says. So it says two things. It says that that line that goes through the midpoint is parallel to BC, and it's also half the size of BC. If these are midpoints and we draw a line through them, that line that goes through them is parallel to the third side of the triangle, third side being this one, and then also parallel to them, to that side. Do you understand?
Yes.
Okay, now I think we can actually go back to our question. So now there it is. Now they're asking you to prove that E is a midpoint of AB. So in math, sometimes what we do is the converse. Converse is like the opposite. Remember what we said now is that if you draw a line through the midpoints, that line is parallel and half the size of the third side. So converse is the opposite. It's like, so converse is like this. So if you compare it to normal language and English, so let's say your theorem is this. Your theorem is that if it's wet on the floor, then it has rained. That's your theorem. Now the converse says if the floor is wet, then it has rained. Oh, what am I saying? No. Let me say it like this. Your theorem is this. If it rains, then the floor will be wet. That is your theorem, right? Do you understand?
Yes.
If it rains, then your floor will be wet. Then this is what converse means in mathematics. If the floor is wet, then it has rained. Does that make sense?
Yes.
So so we're gonna do the same thing here with the converse. So instead of saying that, okay, the original theorem says if we draw a line through EF, if there's midpoints E and F, and we draw a line through them, then that line is parallel to that side and also half the size of that. So now converse is going to say this. We're going to say that if this line is parallel to that line and half the size of that line, then E and F must be midpoints. Do you understand what I'm saying?
Yes.
Okay, so let's start there. So to prove our point, let's work with these two midpoints. So we've been told that F is the midpoint, right? We've been told that F is the midpoint of AC. Are you with me?
Yes.
So F is a midpoint.
Yes.
I'm going to just write midpoint as MPT. F is midpoint of AC. That one is given. We were told. So if F is a midpoint of AC, then we can say that this line FH is parallel to GC.
GC.
We're using the midpoint theorem because we said if there's midpoint and we draw a line through them, then there are those, then that line is parallel to the third side and half the size. So there's that. So we've set our first part. Now so this is in triangle AGC. Let's move over to a different triangle. Let's go to triangle ABG. I'm going to do it in a different color. Let's go to triangle ABG. Triangle ABG. Why am I moving over? Because they told me that H is also a midpoint. Do you see that?
Yes.
So H is the midpoint. I'm going to write it in shorthand. H is the midpoint of AG, and that is also given. That is also given. All right, that is also given. Now, now H is a midpoint of AG. H is a midpoint of AG. That is also given. Now, if H is a midpoint of AG, then what does it prove? Midpoint theorem would say then this line HE is parallel and half the size to BG. Do you follow? Are you listening? Are you following? Are you there?
Yes.
So then that means HE
Yes.
is parallel to BG. And the reason here should be actually midpoint theorem. I'm not writing it in full. It should be here. Remember, you always have reasons in geometry. Everything happens for a reason.
Yes.
So midpoint theorem, that's what it should say there. Okay. Now, with that being said, if HE is a that line is drawn through there, then we know, because this E is also involved in that line, therefore E must be a midpoint, because it's part of the line HE, which is parallel and half the size to BG. Do you understand that? So that means E is a midpoint of
Yes.
of AB. I'm gonna go through this again because it does get a little bit confused. But this is I think the hardest question out of these three. So E is a midpoint of AB. Why? Because E is connected to H, which is H we've been told is a midpoint. And since H is a midpoint, the line HE is parallel to BG and half the size of BG. So then E is connected to H through the line HE. And so then E is a midpoint of the line AB. And then we have now proven it for 3 marks.
Correct.
Do you understand? Are you following? Uzile?
Yes.
Hello? Okay. Now, can we move on to the next question, or do you have any questions you want to ask from this one? Is there any question?
No.
Okay. These other questions are a little bit easier. Let me just choose a darker color. So it says if EH is this one. So what I always advise redrawing, because I redrew when I did this question, I redrew my triangles. So I'll tell you why. If EH is this part, if they tell you it's 3.5 centimeters, and the area of triangle AEH is 9.5 squared centimeters, calculate the length of AB. All right, cool. Not a problem. So what I did here is that I redrew triangle AEH. I redrew it like this. Now, if we use our parallel lines, you'll see an F shape here. Do you see the F shape?
Yes.
So then that means if that is 90 degrees, this is 90 degrees because of corresponding angles. So then triangle AEH
Yes.
is actually 90 degrees, triangle AEH. So there's my triangle AEH. Now with that being said, now we've been told that this is 3.5, and they told us that the area of the triangle, so they told us that EH is 3.5, and they told us that the area is 9.5 centimeters squared. But now, here's the thing. We can actually work out AE, this side here, based on this information. Since they gave us the area and they gave us the base of the triangle, we can use the formula for the area of a triangle. Can you tell me what's the formula for the area of a triangle?
A times B.
It's actually half times
Or half
base
times.
times perpendicular height. Not just height, because there's also something called a slant height, which is not perpendicular. So, what is the base? The base is the bottom side, the flat side, which is actually EH in this case. Half times 3.5. What is our perpendicular height? Our perpendicular height is the EA that we are looking for. And then our area is 9.5. So we have the area. We are using this to solve for side AE. Are you following?
Yes.
Now, when we solve that equation, I'm looking, I did it in my book here. There's my book. I did my working out here. Don't know if you can see there.
Yes, I
Yeah.
can.
Okay. So then you'll find that AE is equal to 5.43. Now I'm going to ask you a question. This is not exactly what they asked you this is not exactly what they asked you. They asked you for the length of AB. But can you tell me what is the connection between AE and AB? How are they related? How is AE?
I think that AE is is part of the side AB, and AE, if you multiply it by 2, will give you AB.
100%. 100%. That is 100%. Why? Because EF, basically this line here, is along the midpoint. Remember we said E is at the midpoint. So here is right at the middle of AB. So AE is half the length of AB because E is a midpoint. So you're 100% correct. AB, to work out AB, we just take the size of AE and we multiply it by 2. Then we are done. So 5.43 times 2. So then the answer we get, what is the answer that we get? It's 10.86. What are the units?
Centimeters.
Just centimeters. I'm just checking if you are awake. Okay. You're doing great so far. Okay. Now we're gonna finish this before the end of the 10 minutes today. So, are you happy with this answer?
Yes.
All right. Now the last part. I'm gonna erase some of this part from question 9.1 because we don't need that anymore. We don't need the proof. It was a proof, so we don't need it anymore. So, I'm trying to just give me a second. Okay. So I don't need this anymore. So we're gonna finish off question 9.3, and then from there we are done. Okay. Okay. Great. Now, so it says now hence calculate the area of triangle ABC. So we know what AB is, right? We know that AB is 10.86. We just worked that out.
Yes.
So that's your perpendicular height, because to work out the area of a triangle, you need your perpendicular height. What don't we have yet? We're missing just one.
BC.
We don't have BC, 100%. But we can work out BC. How can we work out BC?
If we know the length of EF.
We do, in a way, we do know the length of EF. How can we work out the length of EF? EF, let me write it down. EF is equal to, remember we have EH here. So EF is equal to, EH,
EF
remember,
is equal to EH times 2.
EH times 2. So we times that by 2. What is EH? EH is 3.5. EH is 3.5 times 2. So then EF is equal to 7.
7.
But now EF is actually, now what's the connection between EF and BC? BC then is how much?
But EF is half of
BC.
BC, yes.
So BC is how long?
BC is 14 centimeters.
So now we can work out the area of the triangle. So the area of the triangle ABC is equal to half times the base
of the base times perpendicular height.
Times perpendicular height. So half. What is the base? The base is 14
centimeters.
What is the perpendicular height?
10,86.
10,86. What is the final answer? Final answer. Do you have a calculator with you?
Yes.
Okay, tell me the final answer. I know it, but I'm just wanting you to calculate it yourself.
Yes. So I am getting 76,2.
0.02, yeah.
0.02.
What is the units? What are the units? Not just centimeters.
Centimeters.
Squared centimeters. Remember, area is always squared.
Yes.
Not just centimeter. Centimeter is the length, how long. The area is always squared centimeters or centimeters squared. Don't forget that. There must always be a 2 there with the area.
Yes.
Are you with me?
Yes.
Okay. Yeah, then do you have any questions on this question? Do you have anything you'd like us to go through in 9.3 or the entire question? Is there anything that unsettles you?
No, I quite understand it, the whole entire thing.
Okay. I know. I guess my advice. When the more you do these things, the easier it will become. So to wrap up our lessons from that we started yesterday and we finished now, what are the important things you should take note of? Number one, you should know your properties of your shapes, and that's something you started in grade 9. First point is to know your properties of your shapes. So just gonna go through as we close off the last two things. So we started with question 8 yesterday. First thing you should know, properties of your shapes, number one. Number two, you should be able to visualize. That's why you see me, I use a lot of colors. So that's why I advise also for you, print your paper, whenever you're working with geometry, have colors. Make use of colors to make things stand out for you. Number three, be able to read your angles properly, K and M. That is another objective that we've accomplished, being able to read angles properly. We've broken down what diagonals bisect means, 90, 90, 90, 90. This is equal to that. We went through that. And then we know what diagonals are. That's also part of the properties. We've looked at breaking down complex shapes like this. We said break it down always into smaller parts and work your way backwards. Always try whenever you can't figure out something directly in mathematics, it teaches you about life. It tells you trace the steps back. Trace the steps back and you might find the answers. So start from start from your end point and work your steps back. Okay, how did we get here? That is a trick that we also learned today. Like you said, make use of your colors, make things stand out. And then here, the midpoint theorem, different things that the midpoint tells us. It doesn't show us exactly, it doesn't, the midpoint gives us where the middle of the line is. It basically divides the line into half, but we also learned the midpoint theorem that if you draw a line through two midpoints in a triangle, then we get a side that is parallel and half the size to the third side of the triangle, which is that and that. And then we've looked at the area formula of a triangle, perpendicular height, your base, and we've looked at some algebra around it, and yeah, manipulating. So that's what we covered, and I hope it was helpful. Okay.
Yes, it was.
All right. So thank you so much. We are done. Yeah, I wanted to give you an idea of what your lessons are. So we haven't booked any lessons, but I just wanted to give you and your, don't know if it's your mother or your aunt.
My
Um,
mom.
it's your mother. Okay. An idea. So your mother stays in Cape Town. You stay in KZN.
Yes, I
Okay.
am schooling in KZN.
Oh, okay. All right. So yeah, I don't know if you would like to continue with the sessions, but we'll communicate over WhatsApp and see what we can arrange. Then we continue,
Okay.
especially going on to next year. Um,
Yes,
yeah, I think it's better if we start earlier in Jan, because yeah, I'm still available for some time in December, but I think it's better if we start early in Jan. Whenever, but
early
let
in
me
Jan.
know.
Yes.
Let me know. Please
Okay.
work around your schedule, and then we can start early in Jan. From around the 6th of Jan, I'm back from holiday. Then I can start whenever you are ready.
Oh, okay.
Okay. Thank you so much.
Thank you.
Have a good afternoon. I hope to see you again. Bye
Me
bye.
too. Bye.
Bye.